back to eCore Academy, everyone. My name is Anitha Raj, and I am one of the co-founders here, along with my younger brother, AJ Raj. As you can see, today we have a new Algebra 2 lesson, and it is on dividing polynomials. Today's focus is going to be synthetic division. In the last dividing polynomials video, we looked at long division, so please check that out because that will establish a basis for dividing polynomials for you before you jump into this more sophisticated way of doing polynomial division. So you might be wondering, what is synthetic division? And it's just another method of performing polynomial division. Keep in mind that a polynomial is a series of terms, each term consisting of a variable, a coefficient, or a constant, and these variables raised to exponents. And then these terms are combined together using addition or subtraction, or in other words, separated using addition or subtraction. And in this case, all of these terms together in proper descending order is a polynomial. In long division, we pretty much took a polynomial, which was the dividend, and then divided it by another polynomial, a smaller polynomial, which was the divisor, and we found a quotient. In this case, with synthetic division, we can do the same thing, except synthetic division is like a shortcut or a shorthand form of polynomial division, and I'll show you what that means, but it really is such a faster process than long division. The only time you can use synthetic division, however, is when you have a linear divisor. This means that the number that you are dividing another polynomial by, the number that's doing the dividing, that has to be like look like a linear function. So it has to be in the form of x plus or minus some real number. So it has to be a linear divisor, meaning x has to be to the power of 1, and x also has to have a coefficient of 1. So it has to be x, like I said, x plus or minus some real number. So that is a linear divisor. So let's get right into this video. But before we do, I do want to show you this meme I have up here. This is actually Winnie the Pooh, a popular children's a book and TV figure. It says it here, long division of polynomials. This is just normal Winnie the Pooh. And then you see he's in a tux, so he looks a bit more sophisticated and is a synthetic substitution. So synthetic division, although it's not more difficult than long division, it is definitely a more sophisticated way of doing division because it's a lot more efficient, meaning that it'll save you time. And only students who know when to use it, meaning when there's a linear divisor, are going to benefit from this. So keep that in mind because I want to make sure all of you can benefit from this method. Before we jump into the lesson, I'd really appreciate it if you all could like, subscribe, hit the post notification bell, drop a comment down below, and share using our socials. So before we jump into the lesson, just think about this one thing that I have on mind. Whenever we're learning about a new concept that's related to an older concept, what's the best way to understand the new concept? Well, it's by comparing it to the old concept we learned. So that's exactly what we're going to do with the two methods that we've learned, long division and synthetic division. What we're going to do is we're going to have one like polynomial division problem where you're going to have a polynomial divided by a linear divisor. We'll solve it using long division first, and then we'll see how we can solve it using synthetic division so that we can learn the steps of synthetic division through implementation in a problem, but we can also see, do our answers come out the same? So here is long division, and I'm just going to show you all my work, and we're going to just talk through it. So as you can see, the polynomial that's the dividend, or what is being divided, is x cubed minus 14x squared plus 51x minus 54 because it's under the division symbol. We have x plus 2 on the outside, and this is going to be the divisor. You can see it's a linear divisor because the exponent that the x is raised to is 1. When it's 1, it's a linear divisor, and the coefficient in front of x is also 1. So x plus 2 is our linear divisor. When we do long division, what we're going to do is we are going to drop down the first number, x cubed, right? And then you're going to take, what you're going to do is you're going to take your x plus 2 and multiply it times a value that's going to get you this leading number right here. So x plus 2 times what value is going to get us, well, x times what value is going to get us x cubed? Well, x squared. So x squared times x is going to give us x cubed, and then x squared times 2 is going to give us plus 2x squared, and we'll add x squared to the top. Then we're going to subtract this expression right here from x cubed minus 14x squared. Remember to put the x squared above the 14x squared because these two have the same exponent. We're going to subtract these. The x cubes cancel out, and that was our goal in multiplying x plus 2 times x squared. We can then subtract 2x squared from negative 14x squared. We're going to get negative 16x squared. Then we're going to drop the 51x, which is a linear term because the x is raised to a degree of 1. And then we're trying to figure out what can we multiply x plus 2 2 by so that we can get the opposite of negative x squared. Therefore, we can multiply it by negative 16x. Negative 16x times x is negative 16x squared, but we're actually subtracting them, so the negative sign turns the negative sign is going to be positive. This is going to end up being negative 16x squared plus 16x squared, so these will cancel out. Then we can multiply the negative 16x times 2, and we get negative 32x. 51x minus negative 32x is equal to 51x plus 32x. 51 plus 32 is equal to 83, and then make sure you include the x because they have a variable. So we have 83x. Now we got to drop the final value from the dividend, which was a constant negative 54, and we have to figure out what value do we multiply x plus 2 by so that we can get the opposite of positive 83x, which is negative 83x. So we're trying to get positive 83x because we're just going to end up subtracting it anyway. So you can just multiply it by 83. 83 times x is 83x. 83 times 2 is positive 166. I forgot to mention, but this negative 16x, you got to add it to the top right above the linear term, and then you have to add the 83 above the constant term, which is 54. So make sure you're constantly adding the values you're multiplying the linear divisor by. Then we're just going to simplify. The 83x cancels out with the 83x because we're subtracting. Negative 54 minus 166 is going to give you negative 220. This is going to be the remainder, so if this is not equal to 0, there is a remainder because this does not divide perfectly. The x plus 2 does not divide perfectly into this polynomial. So since this is not 0, we're going to take negative 220, add it to the end of our answer up here, which is the quotient, but then make it a fraction and put it over the linear divisor, which was x plus 2. So we're going to take the remainder, make it the numerator, and then we're going to make the linear divisor the denominator. And that is how we would solve using long division. So I ran through that pretty fast because it really should be a review of the last video, polynomial division, dividing polynomials, long division, so go check that out if you were confused about what I did there, but hopefully you weren't, and let's move on to synthetic division. We're going to take that exact same problem with the linear divisor x plus 2 and then the polynomial x cubed minus 14x squared plus 51x minus 54. We're going to use those exact same values, but we're going to see if we can get the same answer but using synthetic division. So with synthetic division, the first thing you have to do is you have to check the divisor. Our divisor is x plus 2. Well, is that a linear factor? The answer is yes. The exponent that x is raised to is 1, meaning it's linear. In addition to that, with synthetic division, we have to make sure the coefficient of the leading term, which is x, is also 1. In this case, it is 1. We don't see any other value in front of x, so we can assume it's 1, so we're good to go. With that being said, now we have to set x plus 2 equal to 0. We subtract 2 from both sides, and we get x equals negative 2. We're going to use this negative 2, and I just wrote a note down here. This only works with linear divisors, so that you can keep that in mind. We're going to take this negative 2, and this is how we set up synthetic division. So just take a second to look at the format. This is how we set it up. As you can see, it's a lot less work than long division. So we're going to take negative 2, put it in a little box, like half a box up here. You can just corner it off like this. And then what happens is we were given that original polynomial x cubed minus 14x squared plus 51x minus 54. What I did was I wrote the coefficients of each of those terms, but I didn't include the x's. So this represents x cubed. We didn't write the x cubed. We omitted that. We just wrote the 1 that's in front of the x cubed. The next term in that polynomial was negative 14x squared. We didn't write the x squared. We just wrote the coefficient negative 14. The next term was plus 51x. Again, we didn't write the x. We just wrote the coefficient, which was 51. And the last term was a constant negative 54. There was no x with it. We can assume it was x to the power of 0, which is just 1. So we just write the constant down here. What we're going to do first is, well, just so you know, we're adding here. So that's why I wrote like an addition sign. You might see this, you might not see it. You might not have to include it in your work, but I just include it so that I can just keep it in my head. What you're going to do is whatever's the first term, in this case this was an x cubed, so like we said, the coefficient was 1. You drop that down below this is technically the equal sign if you think about it. You drop that down below the equal sign. So you take whatever is your first term, drop it down first. Then you're going to take the negative 2 or whatever value you end up having in this box here, multiply it times 1, which is negative 2, and then put it below the second term. So we put negative 2 below negative 14. Then what we're going to do is we're going to use this addition sign, and we're going to add negative 14 and negative 2. That's going to end up being negative 14 minus 2, and that's going to give us negative 16, which we're going to write down here just like we wrote the 1. Then we're going to repeat the same thing. We're going to multiply negative 2 times the negative 16 we got. Negative 2 times negative 16 is positive 32. And we're going to write the 32 under the third term, which is 51. Now we're going to add 51 and 32, and added those together, you get 83, which you write below the bar here. And then next, you're going to multiply 83, which is below the bar. Whatever is below the bar, you multiply it back with the number in the corner. 83 times negative 2 is negative 166. We're going to add that below the fourth term, which is up here, negative 54. So we're going to add the negative 166 below that. If we add these two together, we get negative 220. And whatever, if you right here, think of this like the remainder. If this is 0, you have a perfect division, no remainder left, but there is something left here, which is negative 220. So that is the remainder. So how are we going to interpret this answer and write our final answer? Well, whatever was the x value here, so in this case, this is x cubed, we're going to reduce one exponential value. So since this was x cubed, we're going to reduce that to x squared, and we're going to write x squared with a coefficient of 1 first. This was x squared. This is negative 14x squared. We're going to reduce it by 1 exponential value. We're going to get x and write negative 16x. We're going to use whatever is written below this bar. This was 51x. We're going to reduce by 1 exponential value. This was 51x to the power of 1. If we reduce it by 1 exponential value, we get x to the power of 0, which is just 1. So technically this 83 is going to be 83x to the power of 0, which is 83 times 1, which is just a constant 83. And then we're going to take whatever is left here, negative 220, make that the numerator, and then divide that by the polynomial, by the linear divisor, which was x plus 2. So put that over x plus 2. This is the same answer we got before. So just keep that in mind. You can use synthetic division to save you a lot of time. We're going to jump into a problem just so we understand what this is about. It's going to be a pretty straightforward problem. We're literally just going to be dividing a polynomial by a linear divisor using synthetic division. So you're going to use synthetic division to find the quotient and the remainder if there is a remainder. Keep in mind there's not always going to be a remainder as long as there is a 0 at the end of our polynomial division. There is no remainder. So the polynomial we're dividing is x cubed minus 57x plus 56. Keep in mind there is no x squared term. We kind of just skipped from the x cubed to the linear term, which is 57x. We're going to divide that by the linear factor x minus 7. Keep in mind you got to check that this is a linear factor. That's the only way synthetic division will work. And this is a linear factor because x is technically raised to the power of 1, and there's no coefficient in front of x. So we can use synthetic division here. And here's the solution. So we're going to do, like we said before, check to make sure x minus 7 is a linear factor. Then we're going to set that equal to 0 and try to get x by itself. So we'll add 7 to both sides and get x equals 7. Then 7 is going to be that number we put in the top corner, right? So we're going to put 7 in that corner. Now we got to rewrite the polynomial, the dividend, in terms of the coefficients. We got to get rid of these x terms. So the first term, the leading term, make sure the dividend is put in descending order from highest degree to lowest degree, and this is in descending order. If you don't know what that is, make sure you check out previous videos on polynomials because I covered that in depth. So x cubed is the leading term. We can imagine that there's a coefficient of 1 in front of it, so we can ignore this x cubed and write down 1 first. Then, like I said before, we skip that x squared term. So technically the x squared term doesn't exist, so you can think of it as x cubed, and then you insert an x squared term, but you have something like plus 0 times x squared, because if the coefficient is 0, 0 times any value is 0, so that just cancels out the x squared term. So technically we can, whenever we're missing an x squared or whatever it is, if we're missing a term, like for example, say we were missing this linear term, we would just write 0 in place of it because it's like it doesn't exist in the polynomial. Then we'll go to the linear term, which is negative 57x, ignore the x, and just write the negative 57 coefficient in front. We have 56 last. It is a constant, no x. We can think of it as x to the power of 0, which is just 1, so we're just going to write 56. Next, what we'll do is we'll drop the 1 below the bar, so we have 1 here. We're going to multiply 7 times 1, which is 7, and put that below the second term, which is 0. Then we're going to add 0 and 7, and then we're going to that is equal to 7, so we'll put that under the bar. Then we'll multiply this 7 times the 7 in the corner and get 49, and put that below the third term, which is negative 57. Then we'll add negative 57 and 49, and if you add them, you'll get negative 8. Then we're going to take the 7 in the corner, multiply times negative 8. We're going to get negative 56, and we're going to put that under the 56 at the very end, the fourth term. 56 plus negative 56 is just 56 minus 56, and these will cancel out perfectly and you'll get 0. So what does this 0 mean? It's a remainder, but since it's 0, there is no remainder. So this linear factor divides into this polynomial perfectly, and if we interpret this answer, keep in mind that this 1 was an x cubed. So we're going to reduce the exponent by 1, so this is technically x squared now. So they're going to have x squared. Then we have 7. Well, the second term was x squared, so let's reduce it by 1 exponential term. We get plus 7x. And then lastly, we have negative 8. Keep in mind the negative 57 was an x, like a linear term. So we'll reduce that by 1 exponent. That's x to the power 0, which is 1, meaning the negative 8 is a constant. So our final answer is x squared plus 7x minus 8. So you can see how we simply did that using synthetic division. I know it's taking a while because I'm explaining it in depth to you, but trust me, if you actually do it by hand, you'll be able to finish this problem in 1 to 2 minutes tops. So now let's jump into an application because, again, we're trying to be as advanced as possible, and you're definitely going to encounter applications involving dividing polynomials on assessments. So here's the situation. The polynomial x cubed plus 7x squared minus 38x minus 240 expresses the volume in cubic inches of the shadow box shown below, and width is equal to x plus 5. I'll show you an image of a shadow box in a second. The first problem, there's actually going to be 2 parts to this. The first part says, find expressions for the dimensions of the box. Hint, the length is greater than the height. So I'll explain what all of this means. So here's a shadow box. You can see that there are some shells in it. It's pretty much just like a frame, but it has a bit more depth to it. So you can put like objects inside instead of images, and then it kind of casts a shadow, hence the name shadow box. That's the best explanation I can give you. I'm not a really arts and craftsy person, but there are people who make great shadow boxes. But the problem, the math behind this is the polynomial x cubed plus 7x squared minus 38x minus 240 represents the volume of the shadow box. Keep in mind this shadow box is like a rectangular prism, so you have length times height, length times width times height. So you're going to have a cubic here because you're multiplying 3 dimensions. So this is what represents the volume. This polynomial represents the volume in cubic inches. We're already given the width as x plus 5. So with that being said, we're asked to find the expressions for the dimensions of the box, including the length and the height. So the 3 dimensions are the width, the length, and the height. We're given the width, but we're given the volume as well, but we don't know the height or the length. So we got to figure that out. And I'll show you how we're going to do that using synthetic division. So we know that the width of the box is x plus 5. X plus 5 is actually a linear factor because x is raised to the power of 1. In addition, x has a coefficient of 1, so x plus 5 is a linear factor. In addition, we know that the volume of the box is x cubed plus 7x squared minus 38x minus 240. If you know the formula for the volume of a rectangular prism, its volume equals length times width times height. So technically, x plus 5 times the height times the length is going to give us the volume, which is x cubed plus 7x squared minus 38x minus 240. So if we divide that long polynomial I just said by the width, which is x plus 5, we'll find out whatever the height times the length is. You're just rearranging a literal equation, which is volume equals length times height times width. So what we can do is we can divide. We can either do long division, as you can see up here, but this will actually be time consuming because we have a linear factor, so we can use synthetic division. So we can take x plus 5, set that equal to 0, isolate x by subtracting a 5, and we get x equals negative 5. This will be the number in the corner. X minus 5 is going to be the number in the corner. Then we'll take this polynomial. You can see that's already in descending order, and it's not missing any terms. We got the cube, the squared, the 1 or linear term, and then the constant. So what we're going to do is we're going to take the coefficients and write them down here. The coefficient of x cubed is 1, coefficient of 7x squared is 7, coefficient of negative 38x is negative 38, and we just have negative 240 as a constant out here. Then what we're going to do is we're going to drop the first term, so 1, we're going to drop it down below the bar. We're going to multiply 1 times negative 5 and write negative 5 under the second term, which is 7. We're going to add 7 and negative 5. 7 plus negative 5 is technically 7 minus 5, which is 2. Then we're going to write 2 underneath the bar. We're going to multiply 2 times the number in the corner, which is negative 5, and get negative 10, and write that under the third term, which is negative 38. Negative 38 was then going to be added to negative 10. Negative 38 plus negative 10 is negative 38 minus 10, so we're going to get negative 48 and write that below this bar. Finally, we're going to multiply negative 5 times negative 48. The negatives cancel out and give you positive. 5 times 48 is 240, and we're at the 240 underneath the fourth term, which is negative 240. Negative 240 plus 240, well, those cancel out because they're the same value but opposite signs. So you're just going to end up with 0, meaning there is no remainder. That's perfect. And if we write that as an actual, an answer, the 1 at the top was x cubed. So we're going to reduce the exponent by 1, get x squared. And then the next term was 7x squared. Reduce the exponent, get x. We have a 2 here, so we're going to add 2x. Finally, we have a negative 48. Negative 38 was an x term, so if we reduce the exponent by 1, we'll just get a constant, which is negative 48. What are we going to do with this answer? Well, we had to find what the height and the length are. So what we can do is, what this answer is technically is the height times the length, because we divided the volume by the width. When we do that, we actually end up with the height times the length. So what we have to do is we actually have to factor this, because the factors multiplied together are going to give you this value, and this value times the width is going to give you the volume. So we're going to end up factoring these, and if you look at this, 48, well, 2 factors of 48 are 8 and 6. And how can 8 and 6 be added or subtracted to give us the middle term, which is 2? Well, we can have a negative 6 and a positive 8, and 8 minus 6 is equal to 2. So make sure you know how to factor. That's just basic quadratic factoring, guess and check method. So you end up getting x plus 8 times x minus 6, and if you multiply this, you'll get x squared plus 2x minus 48. Now the problem is, and also we know they're in inches. The problem is, how do we determine which is the length and which is the height? Well, in the previous slide, we were given the hint. Go check that out. Rewind if you need to. We're given the hint that the length is greater than the height. Well, let's pretend. Remember, we're not going to set these equal to 0. That's a totally different situation, so don't get confused with that. Let's just pretend we're plugging in some random number for x. Let's say we're plugging in, the number 12 for x. If we plug in 12 in this x plus 8, we end up getting 20. If we plug in 12x minus 6, we get 6, which is greater. Well, the x plus 8 is greater. Since the x plus 8 is greater, that means this is going to be the length, because the length is greater than the height. So x plus 8 is the length, and x minus 6 is the height. So here's the next part of problem number 4, which is application. It's going to be the last part. Same polynomial, x cubed plus 7x squared minus 38x minus 24, representing the volume in cubic inches of the shadow box. I'll show you the image again. Bam, there it is. And the width is going to be x plus 5 again. If the width of the box, let's say now we're actually finding a definitive value for the width of the box. We're being told the width of the box is 15 inches. We got to find the exact values of the other 2 dimensions. So here's going to be the solution to that. We know that the width of the box is x plus 5. We're also told that the width of the box is equal to 15. Well, you can just set x plus 5 and 15 equal together because they're both equal to the width of the box. So x plus 5 is equal to 15. What we're trying to do is we're trying to find the value of x. And if we subtract 5 from both sides, we get x equals 10 inches. Why are we trying to find the value of x? So we can plug this value into whatever we found for the length, which is x plus 8, and whatever we found for the height, which is x minus 6, to find the actual value of the length and the height without the variable. So we know that the length is equal to x plus 8. We know that x is equal to 10, so we can plug 10 in for x, and we get length equals 10 plus 8. 10 plus 8 is equal to 18 inches, so length is 18 inches. We can do the same thing with height. Height is equal to x minus 6, as we said before. X is equal to 10, so we can plug 10 in for x, and we get height equals 10 minus 6. 10 minus 6 is 4, so the height is 4 inches. And there you have it. So that was the application. Pretty straightforward. So I hope you enjoyed this video. If you did, please like, subscribe, hit the post notification bell, drop a comment down below, and share it using our socials. Also, check out our website and Gmail while you're at it. I will see you in the next video on dividing polynomials. It's going to be on the remainder theorem. Bye!